information then we started to describe our system. So rain started, and the inflow to the wastewater tank increased, and the inflow caused by the rain was 1.5 cubic meters per minute. So this is all initial information. And we also have that our rain was 3/4 of the hour, so it will be 45 minutes. And what else? What initial information we have? We know that initial conditions of our process could be described as initial liquid level, wastewater level inside the tank was 2 meters, and our first pump, is on. So basically, what information we should provide? We should provide graphs. So in that case, basically, this is the height of the tank, and here I will provide how our pumps work. So, for example, this will be the first pump, and here we will have a second pump. So 0, 1, 0, 1. So here we have our graph. So first of all, we should describe our system. So we know that change of the volume inside the tank during the time will be the difference between inflow and outflow. So because basically our inflow remains almost the same, just in some time. So basically we can describe our process as linear. So instead of differentiation, we can describe it as a difference equation. So in that case, basically we can consider, because inflow is constant, so we can consider it like delta V multiplied by the time. So right now we would like to know how water level is changing. So in that case, changes of the height of the tank will be difference in inflow and outflow multiplied by the time and divided by the area of our tank, because volume is height multiplied by the area. Something like that. So basically, right now we can start to describe our process. But first of all, I should describe the law, how our pumps work. So in that case, I know what is the water level. And I have been told that first pump is placed in service at then height is equal to 3. So basically that means that the first pump is turned on at this height and turned out, then height is equal to 1. So as you can see, here we have such a hysteresis. So if water level, of course, can be less than 0, if water level is less than 1, so we don't pump any water from our tank. So again, we have another pump which turn on at height 4 meters and turned off at height 2 meters. So here we have another hysteresis. As you can see here. So this is characteristics of our pumps. So right now I can continue and provide the full picture, how our liquid level changes during the time. So first of all, we have our initial condition. So our initial condition says that we start from 2 meters here, and we don't bother what was happened before that. So we start at this situation, and our first pump is working. So basically here I also know that our pump is working. So right now, knowing that condition, and we know that at the beginning our inflow consists of 2 parameters. First of all, just ordinary inflow, common inflow from different sources, which equal to half of a cubic meter per minute. And I have a rain condition here also. So also per minute. So it will be 2 cubic meters per minute. Okay, because pump characteristic I have in cubic meters per hour, so I should convert it to the right units. So it will be, because in hour we have 60 minutes, so we will have how many if we divide that, we will have
0.95, 0.91.
0.9 cubic meters per minute. Like that. And our outflow will be equal to that value, cubic meters per minute. So first of all, then we change our situation. As you can see, because inflow is much more greater than outflow, that means that liquid level will increase. So when we change our situation, we know that second pump will turn on at the height of 4 meters. So in that case, we will have change in 2 meters. Basically, that means that delta height will be 4 meters minus our present situation of 2 meters. It will be equal to 2 meters. So we know that we will reach the next state after 2 meters. So we should calculate in what time. So in that case, delta T1 will be equal, so we should divide delta H by this, and it will be multiplied by the area and divided by the difference of our flows. So inflow minus outflow, something like that. So in that case, I need to know the area of our tank. So area of the tank equals to P square R, or P diameter divided by the 4. So this will be our diameter is 4 meters divided by 4. So in that case, the area of our tank will be equal to 1256 square meters. So delta height equals to 2. Our area is 1256 divided by 2 cubic meters per minute minus then just one pump is working, so minus 910. So according to my calculations, I will receive that value in 22.8 minutes. So in that case, 10, 20, 30, 40, 50, 60, 70, 100. So 22 something here. I started here, and I will reach this condition. So this is our first case, and just one first pump is working. So basically that means here second pump is turned off and the first pump is working. So this is the time. The next situation, because we have reached 4 meters, so right now we should turn on our second pump. So in that case, because rain, we analyze this situation. Rain lasts for 45 minutes. So basically, we still have this condition that inflow equals to 2 cubic meters per minute, and we have a condition that outflow has been changed, and right now 2 pumps are working because they have the same performance, so it will be just it will be doubled. It will be doubled. Okay, but right now, as you can see, the increase of the height or increase of the liquid level is not so drastic. So basically, we should find. So then, because we know that our rain will last only 45 minutes. So in that case, what height we will reach during that time? So in that case, delta T2 will be 45 minutes minus our first state. So 22 and so on. So in that case, we will have 22.
一块是个诺到们到本说起了。
And we should consider
Chill out
what
ish.
will be the. Can you see it here or not? Yes. Okay. I will continue here. So in that case, delta height at the second state will be, as you can see, according to that law. So inflow, so minus outflow. In this case, 1.8, and divided by the area, which is 1256, and multiplied by the time. So, according to my calculations, we will have 0.35 meters. So, okay, even with such hard rain, we still in our limits. So we will reach the absolute value for that period will be 4 plus those meters, and will be 435 meters. So for that time, our value will increase just a little. So this is the second case, and 2 pumps are working. So third state. So rain stops. That means that basically our inflow will be just half of the cubic meter per minute, just ordinary case. So, but because our liquid level is higher than 2 meters, because we will turn off our pumps. The second one will be the first, and it will be turned off at 2 meters. So basically, that means that our outflow per minute. And in that case, because the change of the condition will be only when we reach that point, so delta height 3 will be equal our actual condition point, okay, I have to find here, 4.35 meters minus then case, then we turn off our one of the pumps. So 235
متوجه اونجا
So in that case, we should find the time during which we will reach that situation. And this time will be, so
سوال
multiplied by
میگه
the area
تو سوال انگار داره
of
میگه
our time
بعد اینکه این پمپ
in
مثلا رسید به اینقدر
نه ببین نوشته کیو آلت خب بعد اونجا میدونه کیو آلت 9 در
آره
بود
مثلا اونها نمیدونم اونها خود سوال داره
نه بابا خودش در آورد 9 حساب کرد اینجا 9 حساب کرد
مثلا برای بود که 9
So
خودش
that
فرق
means
نه
that
واحدش فرق
absolute
داشته
time will be
این متر
45
مکعب ساعت بوده در واقع
plus
چیز
this
در
delta.
واقع متر مکعب دقیقه
And
خب
will be
نه خب درسته ببین اونجا کیو آلت نوشت 12 در 9 خب
تازه که تو
So
سوال
when
تو
we
سوال
have
از
our
موقعی که
time,
مثلا به این حد میرسه پمپ دوباره شروع میکنه نگاه کردن و اون میخواد دو برابر
we
شده
will
تو
reach
میدونی تو خود
this
سوال هست
situation.
تو خود سوال مرحله دوم میتونه باید در این خروجی بشه
This is that point.
تو این دادهای مثلث بود
Third case, and here we have first and the
مثلا
second
این
pump
خودش
working. So basically, was that time we have such situation, and the fourth case. So because second pump is turned off, we still have our first pump. So inflow as usual, half of the cubic meter per minute, and outflow equals to the performance of just one pump. So it's greater than inflow. So basically our levels decreasing, and we will turn off our pump at the height of 1. So delta height will be 2 minus 1 will be equal to 1. So in that case, delta T4 will be equal to delta 8 4 multiplied by the area and the difference between flows in and out. So according to my calculations, we will have 31.4 minutes, and that means that absolute time in that case will be 67.7 plus 31.4. It will be 99.1 minutes. So we will reach this condition somewhere here. This is our fourth linear representation, and only one pump is working. So basically, first pump is working and the second not. And let's just continue here let's watch how level will increase, then our pump is turned off. So at what liquid level we will change our description, so our process changes. At what? Yes. Then we have reached this level. Our first pump starts. So the last description of that process, because it can be continuing. So in that case, our inflow equals to ordinary. Our outflow what is our outflow?
0.
0. So basically we know what is the delta 8. This is the fifth one. So our delta 8 is yes, 3 minus 1, 2 meters. So our delta T will be multiplied by the area and the difference between inflow and outflow. So according to that, we will have 50.24 minutes. So T5 5 will be equal to 99.1 plus this value, so 149.3 minutes. So somewhere here. This turned off, and again, so in cycle. So this is first task which you can have in your exam. How on-off control. So basically, knowing that characteristics, we can analyze that data and we can say what kind of performance we can use pumps. First of all, so as you can see, the load on the first pump is very high. So basically, we always have main pump and additional pump, and we will change those pumps every time. So, as you can see here. Yes?
I didn't get what we had to stop the both pumps because the water level went below 2 meters, below 1 meter. But if the inflow is 0.5 cubic meter per minute, it's 60 cubic meters per hour. So it's a higher inflow in every case than there is an outflow. So the second pump or the first pump should